Hi, I'm Dr. Diana Gragg, and I'm going to tell you about electrification and help you understand all the aspects of electrification. This is just one aspect that we have. This is actually showing you an electric bus. So it's one way of electrifying some of our energy services, which is what we're going to talk about with electrification. So you may have heard this in the news, in the media. What is electrification? What does it mean when you see electrify everything? What we're talking about is electrifying end uses. So that's our space heating, our water heating, some of our industrial services, our transportation systems. That's what we're talking about with electrification. Electrification of these end use services gives us a lot of benefits. And those benefits I put here in kind of the driver's column, but they improve our energy efficiency, they reduce our air pollution, and reduce overall costs and decarbonize the system or give us the opportunity to decarbonize our system. So some of the things that are really important for electrification, why are we doing this? These are our drivers. Big one is that efficiency lever. So with our electrification of services, a lot of times just by providing that same energy service with electrification, you're getting 3 or 4 times more energy efficiency. And so that's huge. And that means that's 3 to 4 times less energy resource we have to find to provide that energy service that we're trying to provide. It allows us to diversify our resources. If you think about vehicles, for example, if we're not using oil to provide our transportation service and we use electricity, we have a lot of different resources we can provide electricity. So from an energy security standpoint, it allows us to diversify the resources that we're relying on for that service. We can also maintain one system. So if we electrify all our services, we're relying on the grid. And if we can invest our infrastructure dollars, our maintenance dollars into one system rather than having multiple systems. So for example, to your home, you wouldn't have both electricity and a natural gas system. You would just have the electricity system. It allows us to put all those dollars into maintaining one system. There's a lot of options in our electricity system that are no carbon or low carbon options. Wind, solar, geothermal, nuclear, these are all low carbon or no carbon options for our electricity system. And that electricity system can get cleaner over time. In other words, if we electrify today, the fuel for that electrified service actually gets cleaner as we're cleaning up the grid. And so if we're looking at like a car, if you have an electric car versus a gasoline car, the fuel for your electric car can actually get cleaner over the life of the car, which you have for 15, 20 years, versus the gasoline car, which is not going to get cleaner over time. And finally, one of the big ones for me in terms of benefits for electrification is really that we don't have air pollution at the point of service. So think about that as like the tailpipe of the car, or for natural gas, it's at the cook stove, or for the water heater. These are air pollution sources in our homes that are right there and impacting our communities and our health. And so if we can reduce or remove those points of air pollution, it is better for human health. So this is why. These are the great reasons why we want to do electrification. There are a lot of challenges for electrifying our energy services. So I've listed those as barriers here, and we're going to go into some of the details here. But we need to have a grid that is able to handle the expansion of demand with electrification, and that includes investment to the grid. It includes investment for electricity generation. So you have to do those expansions and upgrades because you're transferring that energy need from the fossil fuel resource to the electricity grid. A lot of times there's a lot of upfront costs, whether that's in the energy service itself, in upgrading the electrical system in like a building in order to be able to accommodate those electric appliances, for example. So there's a lot of upfront costs. Reliability becomes really important in terms of thinking about, is the electricity available? Now we're relying on one system. How available is it? So reliability becomes an important factor. And then another barrier is just the costs. Even though you're getting those efficiency gains, sometimes the electricity cost design is not optimal for making this the most cost effective. So it's important to think about how the electricity rates are structured in order to encourage all those electrification benefits. So we're going to go through all of these. We're going to do it by going through two examples of electrification grids. One is heat pumps, and the other is electric vehicles. These are two big ones. And so I'm just showing you here, kind of thinking about the system. The heat pump is a way of electrifying your heating services in your home. And heat pumps are much more efficient than like our natural gas furnaces or electric resistance heaters. So this is an important way of electrifying and getting those efficiency benefits and all the benefits we just talked about. And then electric vehicles, same kind of efficiency benefits. Again, this is an electrification of that service. We now have kind of an integration of all of these into one system with our renewable generation, our grid, and our electrified end-use services. So let's talk about heat pumps first. The heating needs for our buildings, both commercial and residential, are pretty significant. So here I'm showing you residential, where our space heating is, almost half of the energy use in our residential buildings, followed by water heating. Both of those can be electrified with a heat pump, much more efficient than their natural gas counterparts. And then I've kind of highlighted a couple other things that can also be electrified. You can use heat pumps on clothes dryers, and you can use things like induction stoves for cooking in order to electrify those services. But you can see how big a piece the heat is, both for the space heating and for the water heating. And then in commercial buildings, it's a smaller portion, but is still significant and still the biggest in terms of space heating of our commercial buildings. You can see it's about a third of the energy in those buildings. So these are the places that we're still using fossil fuels within our buildings that can be electrified through a technology like heat pumps. So how does a heat pump work? I get this question a lot because, one, it sounds magical that it's 300 to 400% efficient. And how can it do it so efficiently? So the big thing to think about with a heat pump is what you're doing is moving heat instead of creating it. And you're taking heat out of a cold space and moving it to a hot space. We already use heat pumps. That's what air conditioners are. That's what refrigerators are. They are heat pumps. So if you want to think about a heat pump to heat and cool your space, you could just put a refrigerator in your doorway. And if you open up the refrigerator, you're cooling your space. And if you turn it around, you're heating your space, because that's what the refrigerator is doing. It's taking heat out of the cold interior of your refrigerator, which you just put your food into and you're trying to cool it, and putting it into your warm kitchen. So this is a heat pump, but at much bigger temperature differentials than we're often using our heat pumps for, because we're trying to cool our refrigerator a lot. The way that we do that movement of heat using electricity is by using some of the physical properties of a fluid. And the important properties of a fluid is that if you compress a fluid, it warms up. And if you expand and decrease the pressure on a fluid, it cools down. And so what we use is a refrigerant, just like we use in our refrigerator, to run this refrigeration cycle for our heat pump and move heat out of the cold space and into the warm space. So what I'm showing you here is an example of I want to use my heat pump to heat my building, because a heat pump can do both. But here I'm going to use it to heat my building in the winter time. So it's cold outside, it's much warmer inside my building. And so there's a process in thinking about this. So if we have a liquid that is low pressure and cold, it will evaporate as it warms up. And you think about this liquid is colder than the air outside. And so the heat, even though it's cold outside, this liquid is even colder. It's going to move heat from that cold winter air into the liquid and cause it to evaporate. And so that liquid changes from a liquid to a gas. It's still a relatively cool liquid, but it has drawn some of that heat from the outside. Now it's a little bit warmer. It's a gas. You're using your electricity to compress it, to push that heat. And so that compresses that liquid, and now that gas is hot. And so you compress the gas. It's now a hot gas. And you're taking it inside your building, and that is now hotter than the warm temperature inside your building. So you cross-exchange it with the temperature from inside your building. That heat will move into the air in your building. So you're heating that air up. As that hot gas gets the heat drawn from it, it becomes a liquid. It's still a relatively warm liquid, but it becomes a liquid. And then you run it just through an expansion valve. So this doesn't take any electricity. You just run it through an expansion valve where you're decreasing the pressure on it again, and it becomes this cold liquid. And so you can run this refrigeration cycle pretty efficiently with just electricity coming in and compressing it and pumping the fluid around and moving that heat from the cold outside to the warm inside. Now, a heat pump can do this the other way too, and you can just switch everything around. In the summer, you can move heat from the cold inside of the building to outside in the warm temperature. An important aspect of heat pumps is the higher the temperature difference it's trying to overcome, the more input it takes. So, for example, a refrigerator is trying to get it really cold. That's going to take a lot more energy than if you're just trying to get it to comfortable space temperatures, but it is going to depend on your environment. Now, you might have noticed in the title, I said air source heat pump. There are a bunch of different ways that we can think about heat pumps and where you're getting that heat from. And if you can make the temperature difference less extreme, it makes your heat pump more efficient. So with an air source heat pump, you're just dependent on whatever the temperature is outside. But you can use a water source heat pump. You can also use a ground source heat pump. The nice thing about a ground source heat pump, which I'm showing you here for both winter and summer for heating and cooling, is that the ground temperature stays a pretty steady temperature, whether it's summer or winter. That's going to be a better either heat source or heat sink for your system. And so you can think about in the winter, it's much easier to take the heat from 50-degree ground versus a 20-degree air. And in the summer, it's much easier to think about grabbing heat or pushing heat into the ground at 50 degrees than pushing heat into the 100-degree outside. And so a ground source heat pump, sometimes they're called geothermal heat pumps. They're going to be a lot more efficient, but they're also more costly. And so this is a challenge when you're thinking about it on the residential scale, but it certainly is an option that can make sense in certain climates. So what is happening in our heat pumps right now? We are seeing growth both in the US and other locations. So here I'm showing you the United States, where heat pumps are now outselling gas furnaces domestically. You can kind of see that the crossovers happened in the last few years. In Europe, we've seen a huge growth in demand for heat pumps as there's been this effort to move household space heating off of natural gas after Russia's invasion of Ukraine and the effort to really decrease dependence on Russian natural gas. And so you can see there was a huge spike in heat pump demand right after the invasion of Ukraine. It still has been pretty high in terms of heat pump demand in Europe. We use heat pumps for other things I mentioned. So you can get heat pump clothes dryers. That's just another way of electrifying it, so it's more efficient than our traditional electric clothes dryers. And then you can also electrify our water heating. Remember, that was the second biggest wedge on our chart for residential. That can also be electrified with a heat pump, much more efficient than using electric resistance. So a lot of applications for these heat pumps, electrifying them and improving efficiency. Other electrification options that are coming in or other appliances include things like induction stoves, and of course we've long had electric ovens and things like that. One of the challenges and one of the barriers I mentioned was that upfront cost for upgrades. A lot of times the residential home will not have an electricity panel or electricity system that is able to handle the electricity draw from these appliances. And so you have to upgrade your panels, which can be very costly. One of the innovations we are seeing from vendors for these appliances is installing batteries within these appliances or within the heat pump, so that that battery can serve as like a buffer for how much power that appliance is drawing at any one time, and can actually allow a homeowner to avoid those costly upgrades to their electricity system, because that battery will make sure that the power draw never exceeds what their electricity system can handle. So we're seeing all these kind of innovations on ways to handle some of those upfront costs of electrification. So we can electrify all sorts of things in our house. This is just kind of an example of kind of putting all together the things that we've just talked about. And of course, reducing air pollution is one of those big benefits we get. We've seen a lot of studies show, especially stovetop cooking, which is often around where people are. Using natural gas can lead to pretty high indoor air quality problems and human health impacts from the pollutants from burning that natural gas in your kitchen. And so electrification using technologies like induction stoves is really great for removing that air pollution point source. It's really important, and we see a lot of benefits, especially in restaurants, where the people are working in the kitchen and at the stove for long periods of time, every day, 8 hours a day. Electrification is really helping to improve the health impacts from the air pollution from the traditional gas stoves. Okay, and a final example on a heat pump, talking about a heat pump at a grand scale here at Stanford. So Stanford, about a decade ago, installed basically a district size heat pump where they're using waste heat from some buildings where they're doing cooling to provide heating service to other buildings. What Stanford found is that buildings required both heating and cooling all year round, depending on the type of building, whether it's a hospital or a data center or a lab space. They were heating and cooling buildings all year round, and so there was this opportunity to move heat from the buildings you're cooling to the buildings that you're heating. And they did this at a scale that hadn't been done before at the time. This is called our central energy facility. And so there's kind of two big things. One is this is using waste heat to provide that service. So it's much more efficient and doing it kind of a giant heat pump. Two, they also have thermal storage, both cooling and heating. And that allows Stanford to be flexible about when the heating and cooling service is happening and when they have that heat available. And so that thermal storage gives you that flexibility in terms of nighttime and daytime and allows you to really meet this demand. So almost 90% of our heating load is now being met by waste heat at Stanford. And importantly, this really dramatically reduced Stanford's greenhouse gas emissions. So it can be done at the household scale, the building scale, or at the district scale in terms of heat pumps. Okay, so that's what I wanted to tell you about heat pumps. I told you I would tell you 2 electrification stories. So now I'm going to tell you about electrification of transportation. So electrification of transportation provides a lot of benefits, which we talked about. I often get asked, well, doesn't it matter what the electricity mix is on whether there's a benefit from an electric vehicle or not? And the answer is yes, but the electric vehicle is so much more efficient that even on a grid that is powered by a coal-fired power plant, you would still get a benefit of that electric vehicle compared to its gasoline counterpart. And like I said, you own that vehicle for 15 to 20 years. That grid, that fuel can get cleaner over time as you go. So here I'm showing you the electricity mix just for the United States. This is a government website that shows how that electric vehicle powered by the average grid in the US would compare to its hybrid or gasoline counterparts. And so you can see even with a grid that's not decarbonized, you still get a lot of benefit in terms of greenhouse gas emissions for your electric vehicle. A big reason for that is that efficiency, it being 3 to 4 times more efficient. And so here I'm showing you like gasoline cars versus electric cars. That blue is basically the service that you're providing. So you're providing much more service from the same input. Part of that is because we have that electric motor providing that service that's much more efficient. And you also get regenerative braking. And so the benefit here is that instead of using friction to slow your car down, you're turning the motor and turning it into a generator and putting electricity back into your battery in order to slow your car down. And so this can be a significant portion of that efficiency gain is just in making good use of that energy every time you're slowing down your car. We see electric vehicle sales growing worldwide, led by China, where now almost about a quarter of the cars sold in the world are electric vehicles. And so we're seeing this electrification happening. This is for basically light duty vehicles, so think this is personal vehicles, but we're also seeing electrification of other modes of vehicles. So here's bus sales, about 5% in 2025 are electrified. Truck sales have doubled from 2024 to 2025. They're now almost 10% of global truck sales were electric. So we've seen massive growth in terms of electric trucks. Two-wheelers and three-wheelers, which are important in many countries, we've seen a lot of growth in electrification of this mode of transport. And this is actually for on-road transport. This is the most electrified segment in the world. Now, for all transport, the most electrified segment is trains. So trains are significantly electrified both for passenger rail and for freight. So you can see it's over 85% of passenger rail is electrified. This is our local Caltrain that was just electrified recently, just a little over a year ago, for our on-campus or near-campus public transportation. And of course, you get all of those benefits we talked about, including the reduction in air pollution from electrifying this corridor. What can that air pollution reduction look like? I think one of the things that the pandemic really showed us was what cities could look like without air pollution. And so this is just showing you one example in India, showing what the air pollution looked like on a typical day before the pandemic, and then during it, and during the shutdown that we saw during the pandemic. And this is the possibility that we're talking about by electrifying these end-use services. Much of the pollution, a lot of times, is from our transportation systems. We also see disproportionate impacts from the air pollution from our transportation systems, which again would benefit from electrification. So I'm showing you here, this is just one that's down local, but we see this everywhere, where communities along our transportation corridors are bearing the highest burden of the air pollution from our transportation systems. In particular, the particulate matter that's coming from our diesel trucks. So electrifying our trucks is a really important aspect of electrification in order to reduce some of these air pollution impacts. And so here I'm just showing you kind of where the pockets of the significant particulate matter air pollutant from on-road vehicles are in the Bay Area. So it's really those highway corridors, which happen to be a lot of times our communities of color and our low-income communities. And so that contributes to this disproportionate exposure and impact for those communities from the air pollution from our transportation systems. Finally, I talked about how we could just have a single system that we are investing in for electrification. So instead of investing in both our natural gas system and our grid, we could just invest in the reliability of that one system. So this is just one example. There are many, many examples in thinking about this, but in the United States, our natural gas systems are aging just like our electricity grid is, and they need upgrades. And so there are some places that are thinking, is it worth that investment to upgrade both of these systems, or does it make more sense to electrify our end-use services and just invest in that one system? Okay, but there are challenges. We need affordable and reliable electricity access in order to be able to provide these services in an electrified manner. And we are still trying to grow our electricity system to meet the demand that we already have. Although we are growing that electricity access, we are also growing population in areas. So this is just an example in sub-Saharan Africa, where the population without electricity has actually remained pretty steady. Even as we've grown electricity demand, because the population is growing alongside it. And so access to affordable, reliable electricity is really important. In the United States, we are seeing electricity demand grow for the first time in decades. A lot of that is driven by data centers and AI. But you can think about if we are also doing fuel switching from our natural gas and our oil systems to our electricity system, that is also going to increase our demand. And so we have to be smart about when, how, and where we're adding this demand to the grid. because there is spare capacity. It's just at certain times of the day and certain times of the year. And so we have both supply side and demand side ways to do this in an affordable and equitable manner. And of course, reliability also comes in. So if we're thinking about putting all of our end-use services on one system, reliability becomes even more important than it is now. And so what I'm showing you here, this is just for the average annual electric power interruptions by state in the United States. For 2024, you can see the average somewhere around 11 hours of being without power, but there's a lot of variability depending on what state you're from. This is true globally as well. And so the reliability of our electricity systems becomes more important. Outages become important. And we're seeing continued strain on our electricity grid because of climate-related weather events. And so this also impacts the reliability of our electricity system. Some of the things we can do in addition to just hardening our electricity system is also design our buildings in order to be able to ride through these power outages. And so if we think about making our buildings as efficient as possible, they can ride through temperature changes, they can ride through the electricity outages without changing a lot of the comfort of the inhabitants and without having these huge demand spikes when you have an unusual cold snap or something, for example. So this is just an example of windows being an important part of that, but there's a lot we can do in making our buildings more efficient to be able to ride through these outages. And so one example I just wanted to bring up, this is something that was talked a lot about here in the United States, is in 2021, the polar vortex in Texas that led to widespread power outages and price spikes in electricity for those that still had access to electricity. And so these can be life-threatening weather events if you don't have the right infrastructure, you don't have the right efficient buildings in order to be able to protect human health and life through these events. So it is an important aspect in thinking about reliability and electrification of our end-use services. It's also important to think about how we pay for our electricity. So in the United States, in our electricity bills, we're not just paying for the energy that's providing the electricity for our services, we're paying for the transmission, the distribution, the reliability of our system. And how we structure these for customers is really going to impact whether our electricity system and our costs are shared in a fair and equitable manner that supports electrification and all the other benefits that we've talked about. And so how we set up our pricing for our electricity is really important. Now, taking a step back and looking at the global scale again, when we're thinking about electrification and the energy security aspect of electrification, remember we diversify our resources. We can also, through electrification, we can reduce our reliance on a single fuel. That gives us a lot of energy security benefits and allows us to even be able to supply some of our end-use services with domestic resources. And so there was a recent survey looking at the geopolitical instability challenges globally. This was in particular following the Israeli-US war in Iran. And the survey of business leaders and how important electrification is for geopolitical stability. And so you can see that there's a wide range of countries that were surveyed, but by and large, companies are thinking electrification is really important for all of these reasons here. And these reasons can be kind of put into three big categories. One is the energy security and just having the diversity of resources for electrification. Another is that air quality and public health aspect of electrification. And the third is really that cost competitiveness and being able to diversify those resources for electrification. Electrification can also allow consumers some flexibility that also can be a cost savings or even get paid for benefit of electrification of our services. And one of those aspects can be done with something called a virtual power plant. Now, a virtual power plant sounds magical, it's virtual, but it's a power plant actually providing a service. What you're doing is you're aggregating your electrified services and allowing flexibility on when those that demand is happening, and that provides a benefit that is actual cost savings to yourself, or a benefit that the grid is willing to pay for in terms of reliability. And so a virtual power plant is an aspect that people can actually get paid for allowing flexibility on when they have those electrified services happening. So just giving you a sense of what does that kind of look like. This is just one residential cost rate from our local utility, showing that in California during the day is when our electricity is cheapest. We have a lot of solar that is really low cost or zero on the margin. And so this is when they want electricity to be used, and not in the evening when the sun has gone down. That's when electricity gets really costly to supply. And so a virtual power plant and aggregating those services can actually help move the electricity demand to this low cost time and pay consumers for that service. So it gives these additional economic opportunities. Finally, big picture, decarbonization is happening, electrification is happening, decarbonization of our power system is happening. We're seeing electricity share grow as part of our total final energy consumption, that's electrification. And we're seeing our renewable share of electricity generation grow. We want to continue to grow both of these things in order to decarbonize our systems. And so the questions are, can we continue to grow electricity access faster? And can we continue to decarbonize our grid faster than we're electrifying? And even if we don't, even if there's some bumps along the way, remember that you're keeping that car or that heat pump for decades, and that electricity can get cleaner over time. So electrifying now still makes sense, even if we're not decarbonizing our electricity grid as fast as we're electrifying. But the good news is that solar and wind are our fastest growing energy resources, so we're continuing to accelerate this decarbonization. Okay, I hope that helped you understand electrification and what people mean by electrify everything. If you want to learn more about this topic or other energy topics, visit our Stanford Understand Energy Learning Hub for free resources, including signing up for our monthly Energy Spotlight. Don't forget to subscribe to our YouTube channel and tap the notification bell to be notified for our newest content.